For 1996 Workcell, I'm Nate Clark.
I'm Chris Sheldon.
Jennifer Schemberg.
I'm Chris Thornton.
We make door handles for the Isuzu Rodeo.
And we took third place at national competition. The process is begun by pressing a push button over on the far side of the cell. It raises the control panel and the operator presses the operator start button and then presses the opto touches to start it. The robot now will go pick up the bottom base piece to the part. After it picks up the base, it will take it and place it in the reorientation station.
Might be Nancy.
After it sets it down, it will now go pick up the handle part. It will pick up the handle and place it into the base in the reorientation station. After the robot has placed the handle into the base, it will back off and rotate it. It will now take the part and place it into the assembly fixture. Set the part down and clamp it. It will now go pick up a pin to place in the assembly station. After it sets the pin down, it will now go grab a spring and take it over to the assembly station. It will place the spring in the part. After it is set down, the robot will back off and push the spring down, and the fixture will assemble the part. The robot will now pick up the part and place it into the part chute, and it will be counted by a relay. And that concludes the assembly process of our part.
The cell is started by the opto touches. The opto touches are also used to pause the cell. The opto touches have an anti-timeout circuit, so nothing can be left in the opto touches for more than half a second. Restarting the cell. The cell can be stopped by either breaking the light curtain, or by pulling the emergency pull chain that goes all the way around the cell. Oh, or the emergency stop on the control panel. Control panel raises for to save space and it has a switch strip on it, so if you have your fingers in it, it raises. It goes right back down. We have physical barriers and signs on our cell, and safety tape to know where the holes are for the feeders. Feeders, we have loading compliance and safety tape. We also have signs to tell you what part to put in the feeder. There's a light curtain along the back side, and we also have the safety chain holder. We have air lockout on our cell, which the air can be locked on or off. We also have a slide valve to release the air from the line. We also have a power lockout box, which the power can be locked out on our cell. This is our PLC. We have a valve board with more valves than we need for further cell expansion.
This concludes our 1996 Workcell.
This is our external input and output box for the scorebox controller. And it comes out from the front of the controller, so we don't have to use the inputs and outputs on the front of the controller. These are the interlocks between the scorebox controller and the PLC, and the PLC and the scorebox controller. These are from the PLC, and these are from the scorebox controller. We only have 4 and 4. These are 12 volts, and these are 120. These are all the sensor relays. We have 4 12 volts and 1 120. That is for the siren relay. This is the sensor to detect whether there is a handle present and is a photoreflective. This is the sensor to detect whether the base is present and it's also a photoreflective. There's a photoreflective in the drop-off chute, so when a part passes through, the counter counts each time. It's mounted right about here. The reorientation station / assembly fixture has a photoreflective on it also, to detect whether the handle is present. On this fixture there's a limit switch to detect whether the base part is properly set down, and there's also a proc switch to detect whether this is down or up, and there's also a proc right here to detect if the pin has gone through or not. This is a proc switch for the spring, to detect if the spring is in the right position. There's also a limit switch on the pin, to detect if the pin is there or not. It has an off and manual override feature, where when it's in manual override, you can press the function buttons to fire individual things on our cell. It has a flush pressure regulator and a shut-off valve, and also a gauge. When you press the operator start, the 2 opto touch. The opto touch buttons flash, signaling the opto touches for the operator, and after they're stop flashing, that means the cell is running. To pause the cell, you place the finger in the opto touch, and the cell is paused. Anodine time on circuit for the opto touches makes that somebody can't set something in the aftertouch. You see the lights on, and go over here and put your finger in this because it won't start. You can only have something in there for less than half a second. Not anymore, because after that it disables the circuit. One light is on when the scoreboard is actually moving. When the scoreboard is not moving, the yellow hold light comes on, and the emergency stop light comes on when any emergency is in the cell. Then it returns to the robot not moving light, and then it goes back to run, and you run the robot. When you no longer want to run the cell anymore, you turn the air to the off position and lock it.
I'm bleeding.
And we also can bleed the air so there's no pressure left in the cell.